Assalamualaikum warahmatullahi wabarakatuh. In this video, I will explain about the tutorial for question number 1. I think some of you might have some difficulties on answering this question. Okay, this is the question. Water is flowing at a rate of 2 meter cubic per second through a tube with a diameter of 1 meter. If the pressure at this point is 80 kilopascal, what is the pressure of the water after the tube narrows to a diameter of 0.5 meter? So given that the density of water is 1 kilogram per liter. So here we can see that the density given in this tutorial is in kilogram per liter. So it is compulsory for you to change this unit into SI unit, where the density of water unit should be in kilogram per meter cubic. So this question is actually, if we draw a picture, okay, if we draw the figure, so the diameter of a tube is initially at 1 meter and then reduced to 0.5 meter. So we can draw in decreasing diameter of tube. So here we have this diameter, tube diameter is 0.1, it's 1 meter. Whereas for the second diameter is 0.5 meter. So the flow of water is from the section 1 to section 2. Okay, so what is the aim or the objective of this question is to find what is the pressure of water after the tube narrows. So we have to find what is the pressure at this point, so P2. Do we have pressure 1? Yes, because in this question, the pressure at point 1 is 80 kilopascal. So please remember that P1 is in kilopascal, therefore we have to change into 8,000 pascal. Kilo is just times 10 to the power of 3. So 80 kilopascal should be 80,000 pascal. So that is the point number 1. So P1 is 80,000 pascal. So we have to calculate what is the pressure 2. So we know that in Bernoulli's equation, we have 3 different energy terms, where we have one is pressure energy. Second is kinetic energy. And then third is potential energy. So take a look at one by one of these energy. So for a pressure energy, we have to have P1 and P2. So in this question, we are required to find what is the pressure at point 2. Point 1 pressure already been given in the question. So let's take a look at this P1 is given, P2 is not been given in the question. This is the aim of this question. So next we take a look at the kinetic energy. What is the info that we need in order for us to solve the kinetic energy? So we have to have velocity at point 1 and velocity at point 2. So let's take a look at these two velocity. So in this question, the velocity at point 1 is already been given. So 2 meter cube per second. So velocity 1 is given. What about velocity at 2? So velocity at 2 is not being given. Okay. So can we solve this unknown? Yes, by using continuity equation. So this velocity can be further removed or release the unknown terms by using continuity equation. So we can solve the U2 value. What about the potential energy? Potential energy, we have to have Z1 and Z2. Okay, previously I've already give some guidelines in the video where how to find Z1 and Z2. At this point, Z1 and Z2, our point for section 1 and section 2 is in the middle of this pipe, okay, or tube. So therefore Z1 and Z2 have the same height or elevation. Therefore, at this point, Z1 and Z2 can be removed, or zeroing these terms in our Bernoulli's equation, because Z1 and Z2 have the same magnitude or values. So when we rearrange the equation, Z1 minus Z2 or Z2 minus Z1 will be 0. So we will zeroing these two values. So we can cancel out these two values. So now, as we can see here, we only have one unknown, which is P2. Therefore, we can solve this question. So let's solve this question first. Okay. Now we want to find what is the area 1. So area 1 is pi. We will use pi d1 square over 4. This is cross-sectional area because the flow of water is at cross-sectional area. We do not use pi dl because pi dl is a surface area. Now we have to find what is the cross-sectional area at point 1. So pi, so diameter 1 is 1 meter square over 4. From here we will get the value of our area 1 is 0.785 meter square. So that is area number 1. So what about area number 2? So area number 2, we will use the same equation as A1. So pi d2 square over 4. So substitute the diameter at point 2. So pi, so the diameter is 0.5 meter square over 4. Here we will get the value of A2 is 0.196 meter square. So now we already solved these two equations, okay, A1, A2. I'm so sorry because I've said that the kinetic energy U1 is already been given. So here 2 meter cube per second is discharge rate or volumetric flow rate. So from volumetric flow rate at point 1, at diameter 1, we have volumetric flow rate 2 meter cube per second. So please remember that the diameter volumetric flow rate at 2 is also 2 meter cube per second, but the velocity at 2 is different with velocity at point 1. So you do not have to conclude, you are forbidden to conclude, okay? You cannot conclude that velocity at point 2 is the same as velocity at point 1, because when we have change of area, then therefore the velocity of these 2 points will be different. So remember, when the area is reduced, velocity will increase. So here from 1 to 2, so we know that point 2 will have high value of velocity compared to point number 1. So let's take a look at this velocity. So we have to find what is the velocity at point 1 by using 2 meter cube per second. So we are actually can calculate both of velocity. since this question given us with the value of volumetric flow rate, therefore we can find by using a simple equation Q sum equal to, we will use the discharge equation, which is Q equal to U A. So from here we rearrange to find what is U. Okay, Q over A. So now we have to find what is the velocity for U1 and U2. So now here we have A1 and A2. Now we calculate velocity at point 1 is volumetric flow rate divided by A1. So we have volumetric flow rate is 2 meter cube per second. So we divide by 0.785 meter square. So we can cancel out meter. This unit will left with meter per second. So this we will get 2.548 meter per second. That is our U1. So solve for U2. So we have Q equal to Q over A2. So volumetric flow rate will be the same because it will not move to other location, or it does not have separate or junction that will divide the flow rate into two different area. Okay, so we have only one area 1 to area 2. So substitute the value 2 meter cube per second divided by, so we have already calculate the area for A2, which is 0.169 meters square. So from here we will get 10.205 meter per second. Now we already solved for the velocity 1 and velocity 2. So now we have to change the density of water. We know that the density of water given is 1 kilogram per liter. So therefore we have to change kilogram per meter cubic. So 1 kilogram per liter times with 1000 liter sorry, not 1000 liter, 1 meter cube so kilogram per liter, sorry, 1000 liter per 1 meter cubic. Sorry, I have wrote down the wrong conversion. So here 1000 liter is equivalent to 1 meter cubic. So we have to cancel out. Then we have 1000 kilogram per meter cubic. So now we already changed rho or density of water from kilogram per liter into kilogram per meter cubic. So we already have all the values to be substituted into our Bernoulli's equation. Next, we move to Bernoulli's equation. So P1 over rho G plus U1 square over 2G plus Z1 equal to P2 over rho G plus U2 square over 2G plus Z2. So previously I've already mentioned that Z1 and Z2 is the same, so we can cancel out these two terms, Z1 and Z2. So we left with this equation, P1 over rho G plus Z1 equal to, U1 square over 2g equal to P2 over rho g plus U2 square over 2g. So our objective here is to find what is the pressure at point 2. So rearrange this equation. So we have P2 over rho g equal to P1 over rho g plus U1 square over 2g minus U2 square over 2g. So P2 is, we have to multiply both of these equations, left and right hand side, with rho g. So we will get P1 plus rho U1 square over 2 minus rho U2 square over 2. So we have to simplify this. So P2 is P1 plus rho over 2 U1 square minus U2 square. Okay, that is our equation for Bernoulli's equation. So we already simplified the Bernoulli's, and then we know that P2 is P1 plus rho over 2 U1 square minus U2 square. So you have to substitute all the values inside this equation. So we will get that P2, okay, P2 equal to, P1 is 80,000 Pascal plus, okay, we have density of water is 1000 divided by 2. Now velocity at point 1 is 2.5, 48 square minus 10.205 square. Okay, now we have P2 is 307.14.9 Pascal. Or you want to change it into kilopascal, so you have to divide by 1000. Okay, 1, 2, 3. So you will have 30.715 kPa. So you already solved the tutorial problems, tutorial question for